Thanks everyone for coming. It's great to see all the interest in Amazon Web Services. My name is John Phillips. I'm a product manager in EC2 with the responsibility for our GPU infrastructure products. Getting straight into it, for the first half of the presentation, I'll provide a quick overview of AWS and our history with NVIDIA GPUs. Next, I'll dive a bit into the media vertical and talk about the drivers of AWS consumption in that space, along with current trends. Bhavik from our partner team will profile a few companies that are doing things on Amazon and also talk about vision for the future in the space. And we're privileged to have Jules Urbach with us here today to talk about how that vision is rapidly becoming a reality with OTOY. So we're often asked the question, how did Amazon.com get into the cloud computing business? And the quick answer is that about 10 years ago, the technical team supporting the retail business adopted a service-oriented approach, meaning they easily packaged our technology infrastructure so that deployments were faster, they were easier, and they were more scalable. And we quickly found out that developers outside of Amazon were hungry for this type of approach. And so Amazon Web Services was born, where infrastructure could be provisioned quickly on demand. And so just a quick view of what is AWS. At the core, you see we've got compute, storage, and database services. And now with NVIDIA GPUs and Amazon EC2, we also include graphics in our core. These core services are supplemented by things like management tools and networking services and application augmentation services, all hosted on our global infrastructure so that you can deploy IT infrastructure globally without having to purchase any equipment. And so why are customers adopting cloud computing? Here on the screen now are a few reasons why. One big thing is replacing big capital expenditures with variable expenditures. Another is the economy of scale we offer. With our scale, we can both drive down our costs and drive up our utilization so that the prices that we offer can be lower than a lot of companies can achieve on their own. There's elastic capacity, so there's no need to actually guess at what kind of compute needs you'll have, over-provision for peak, and then end up underutilized. Speed and agility, you can get infrastructure in minutes, not weeks. You can go global in minutes and reach a global audience very quickly. And finally, you can stop paying for undifferentiated IT heavy lifting and focus on your core business. Next, I want to dive into a specific aspect of our business, the core compute and graphics. And this part of our business is delivered in the form of virtual servers that we call Amazon EC2 instance types. Amazon EC2 offers a broad selection of instance types to serve a diversity of workloads. And you can see that we've been iterating quickly on behalf of our customers. One thing I want to focus in on here is our GPU instance types. And generally speaking, our instance types are categorized. They have a CPU focus, a memory focus, can have a storage focus, an IOPS focus, and then we have GPUs. So we got into the GPU space over 3 years ago with the CG1 4 extra large, which is what we called our virtual machine with NVIDIA Tesla GPUs. And since then, we've received a lot of feedback, and just 4 months ago, we launched the G2 2 extra large, which we believe accommodates a lot of the feedback we got after launching CG1. And that includes things like customers wanting much lower price, wanting a single GPU per instance type, wanting graphics API support was a big one, and lots of interest in new technologies such as the frame capture and encoding APIs NVIDIA developed. So that brings us to where we are today, which is Amazon Web Services with a virtual server offering that includes NVIDIA GPUs. Now to dive a little bit into the media vertical. Media on the AWS cloud today, if you look at a typical end-to-end media workflow, you can see that many media companies are using it for the business-to-consumer component. They're doing some transcoding, some rendering possibly, but mainly distribution at scale. there are many other upstream components to the media workflow that are emerging on the cloud, but not quite there today. There's still a long way to go. And the key drivers for distribution at scale on the Amazon cloud include more content choices, meaning there's an exponential growth in content and content formats, which increase storage requirements. And so you see with an exponential growth in content and interest in the cloud, more devices to consume that media. With all those devices comes the proliferation of content formats, increasing the need for transcoding and processing. And so you see a lot of interest in the cloud for scaling up processing resources, creating these new distribution formats, and putting them in cloud storage, shutting back down the compute nodes. There are more ways to get the content to devices. So once you've ingested the content, you've transcoded the content, and you're storing it, then you need to get it to your end consumers. And that involves scaling up origin servers, which is something that's done on EC2, and you scale them back down when you don't need them anymore. And that's also, distribution also happens with our content delivery network, where we have edge locations all over the world to get low latency connections with consumers. And finally, new experiences. So there's a lot of competition for consumers' attention in the media world today. And a couple of the challenges include content discovery, helping consumers find the right kinds of content. Another challenge is getting a good customer experience across devices and across media. And what this means on the back end is a lot of data processing about metadata about your customers and metadata about their contexts to try to deliver them personalized, customized experiences. And one overarching trend here is that content movement will continue to be the heavy lifting of media workflows. There's this idea of data gravity where where the larger data, the bigger data that you have in a location, the more costly it is to move, both in time, data transfer time, and dollar expense. So data likes to sit where it is, and it's important to be with a cloud provider, an infrastructure provider, that can have an ecosystem of services that can bring processing and bring work to the data rather than requiring data to come out for work and processing. And so now I'd like to introduce Bhavik. He's from our partner business development team. He's going to talk about a few companies that are leveraging the AWS cloud today.
Thank you. Okay, so like John said, I work for the AWS partner team, so we thought it might be useful to highlight some use cases, real use cases in the production and broadcast and theatrical television and studio workflow, just to give you highlights of what actual customers are doing today. The first one is Netflix. A lot of people have heard about Netflix. Clearly, I'm sure many of us here are subscribers, but they're a very interesting company when it came to their whole philosophy about shifting their entire business IT infrastructure to the cloud. So virtually 100% of Netflix is cloud-based, and large majority of that is on AWS. And clearly, from a consumer perspective, you see this very rapid distribution chain that they have from taking content and distributing it to globally different countries, transcoding it for multiple different screens, multiple different devices, and providing that user experience and user discovery. So many services and tools, and specifically as we narrow in on the use case of CPUs, GPUs, transcoding becomes an incredibly important component of this. Repurposing existing content for new platforms, transcoding new input that comes from studios and broadcasters for distribution. But this job is massive, it's complex, and it doesn't get any simpler as you begin to scale out your user base and distribution sort of from a global perspective. The next very interesting one is one of our partners called Elemental Technologies. Now, Elemental, I believe they'll be speaking here today, and they've been a pioneer of both GPU and CPU usage. They've built a transcoding appliance from the ground up, all in software. It leverages both GPUs and CPUs depending on your transcode workload. So specific broadcast formats might take advantage of certain different types of hardware. And so they've been running their software on both types of platforms for a considerable number of time, and have racked up some fantastic customers and great penetration in the broadcast industry. What's specifically interesting about their adoption of the cloud is that they've taken their software appliance that would be sold as hardware on premise, and they've taken that entire software stack and transported it to the AWS cloud. So you can now take advantage of NVIDIA-type transcoding, leveraging GPUs specifically as a managed service available on the cloud. And this allows you to both input and output broadcast quality formats in a variety of different, and retranscode them into a variety of different formats for different playout devices. And so one very interesting example that's very pertinent to a broadcast workflow is the BBC. The BBC actually spoke at our user conference in late November about this use case, where they're essentially taking content that is 60 minutes from playout on terrestrial television to being available online. And that's taking assets, it's transferring them to the cloud, it's repackaging them, reassembling them, retranscoding them for multiple different devices, and then prepping them for playout on the BBC iPlayer. So this is a very interesting work case. Use of the cloud allows them to scale up, to scale down, but also to preserve their broadcast format and workflows in a highly elastic and scalable way. Moving up the production chain into post-production, Zync render becomes another interesting example of now visual effects rendering in the cloud. And Zync Render has built their platform. They've been operating for about 4 years. They've produced over 20 feature films on top of the AWS platform through their rendering service. And that's over 500,000 frames that have gone into these movies. So what they're really transforming from a visual effects perspective is this shift from CapEx to OpEx. To really only spend what you need when you need it without having to have this massive upfront CapEx investment to build a business. And so specifically for Zync, some of the notable films that they've produced via their AWS-based service, American Hustle, Looper, Flight, the latest Star Trek movie, Into Darkness, and the Transformers movie. So we've all hopefully enjoyed these movies, but it's very interesting to note just how the use case of AWS from a pure media and entertainment perspective is shifting from just online distribution to much more of the more complex tasks that have to go on in creating content. And specifically bringing back to the GPU use case, so Zync is actually working on an expanded service offering in their platform that will support GPUs, and specifically for outputting from the Foundry's NukeX product, which does restoration and transformation at the frame level. And compositing, that's the other piece. So what's next with this workflow? So as John had mentioned, we've historically been used in our 8 years of existence, historically used in the online distribution piece. So that's multi-screen, multi-device distribution, generally B2C. What we see is an expanded view now, though, as we move up that value chain and that content creation chain into post-production and then potentially into production to really offer the power of the cloud to content producers and creators. And that's specifically around storage, so capturing 4K, 2K, 8K frames, storing them, being able to search them, being able to compile them together for visual effects purposes or for repurposing purposes. And so this is what we see the shift occurring, and some of those examples, broadcast and film, give you very interesting pointers into what we see coming in the future. And so specifically what we see next is really that post-production tool set. So nonlinear editing, more visual effects applications, more rendering services, more content finishing and rough cut and collaboration, and everything that you need to do from a production workflow perspective between businesses prior to creating content. So review and approval, dailies, end-to-end workflows. So NAB will start to see some very interesting advances in this field. We have some pointers, and there's some, what we see as very interesting innovation and cloud adoption coming up in the future, which allows me to make an awesome intro to Jules that's going to actually show you what can and will be done in the future.
Thank you very much.
You're welcome.
If you come up and add the mouse. I got it. All right. Well, John, first of all, thank you for inviting OTOY to your presentation. Our story on Amazon really begins with the launch of GPU instances in the cloud. We're a GPU graphics company. Our ultimate goal is to deliver unlimited compute and rendering power on demand to any device, and to work with partners that have the same vision, and ultimately to empower creators to build new types of experiences and content that is really outside the scope of what you can get on a device in the traditional sense of a PC or a mobile embedded system. And we use Amazon really to deliver this experience in 3 layers. And the first layer is essentially a virtual machine that is available in the Amazon Web Services Marketplace. It covers operating systems ranging from Linux and Windows to specific isolated sandboxes that allow you to take a Windows application and put that in the cloud and deliver that to a web page. And so in that column on the left, we provide users with and Amazon developers with the ability to really have very low-level control over the operating system. The layer above that allows us to add applications, and typically those are existing Windows applications such as Blender. Specifically, in our launch in November, we brought in Amazon as a partner, and we built a virtual machine that had Autodesk Max, Maya, and Revit and Inventor installed. And this means that that those applications don't need to run on a PC. Those are typically very heavy Windows applications, and through Amazon and NVIDIA Grid GPUs in the cloud, we can deliver that to the browser. And this third column is really where we see GPUs in the cloud providing something that is totally unique relative to what's come before, and that is really infinite cloud rendering capabilities. And we have 2 services that we've begun to roll out on Amazon G2 instance types. The first is Octane, which is used for final rendering at the highest possible quality for films on GPUs. It's 100% written for GPUs, and it's pretty unique in that perspective, especially for films. And a new service that we just announced a week ago that will be coming out in the second half this year is BRIGADE. And it's similar, it shares some similarities to Octane, but it's designed to deliver next-generation cloud games also on Amazon, also leveraging really as many GPUs as necessary to deliver what is essentially a completely photoreal experience. The Amazon Marketplace is really where customers begin. They have a choice of different levels of entry into our ecosystem. Typically, about half our customers start with the Autodesk VM, which comes pre-installed with Autodesk software. And on the client side, we've established a partnership with Mozilla to enable essentially zero client streaming. In other words, there is no plugin, there is no native code necessary for you to access any of our software on Amazon. It all runs in JavaScript. And that is something that I think is such a unique twist on streaming and remoting that we ended up really getting a huge amount of support from Mozilla, specifically Brendan Eich, who is now the CEO, and he's been a great advisor to the company. He's really helped guide the OTOY's web platform in really interesting directions. And so in partnership with Amazon and Autodesk and Mozilla, we've really seen incredible adoption across various different industries that really have been hungry for the ability to stream applications and advanced graphics without any friction whatsoever. In this case here, this was from a review that Archintosh, which is a Mac blog magazine, and they basically took our Amazon instance Autodesk product and they tried to run it in Chrome on a Mac, and it works. And it's really, for them, it was a revelation because Revit and Macs have never worked on the Mac, and here they opened up Safari or Chrome, and these applications are there. And it was, you can go on the web and read about their experiences. But this is pretty typical of what we're doing to change the world as far as, moving people from Windows and even thinking about a desktop to something that is very different. And sure, we're starting with existing Windows applications or Linux applications, but the future is really about the services we can build on top of those things. And first and foremost is Octane. So if you see that window in the middle there's a render of a scene that is using one GPU, but it can also be using an unlimited number. And let's see if I can play this video here. We haven't shown this publicly before, but one of the things that's really interesting about our service is that this is running on an Android tablet in JavaScript. And it can stream not just 3D Studio Max, it can stream Steam, it can stream anything. And there's no app store, right? There's no, you don't have to worry about Google Play or iOS's rules. It's just anything that you can put on Amazon and NVIDIA GPU hardware, on Windows, on Linux, is now one click away in the browser, and there's nothing that will stop you from accessing that. And historically, there's been some friction there. I mean, OnLive had a iOS client that they could never launch because Apple would never approve it. With this technology, that's now moot. And so it's very exciting for us to be able to sort of develop this. Certainly, as mobile devices improve, as browser support improves for WebGL, this becomes viable. This particular stream is running at 720p 30, but by the end of the year, we expect this very same tablet to be able to deliver 2560 by 1440 at 60 hertz, and that's pretty remarkable over just typical LTE. Focusing a little bit more on what we can do above the application layer, Octane is again a game changer. We've always been very focused on GPUs as a rendering solution because they're cheap, probably an order of magnitude cheaper and faster than the equivalent CPU. Certain rendering issues have been very hard, in other words, path tracing and ray tracing, but we've largely solved those and deliver final renders that are higher quality than what you could do on a CPU. And they're done in a very inexpensive and efficient way. And we can leverage and stack GPUs together on across multiple Amazon instance types and deliver as much rendering power as you need inside of Autodesk applications like Max, Maya, AutoCAD, and so forth. And these images basically show the built-in photorealism that we have on this in this technology. And this is something that is not just used for films, but also something that we can apply to virtual worlds and games. This particular use case is from one of our users that has basically leveraged Octane to deliver what we think is a pretty remarkable experience, just using 2 GPUs. And typically these kinds of scenes would be rendered, it would take hours to render, it would cost a fortune. And so on Amazon with GPU instance types, we can deliver virtual worlds, virtual renders that are above and beyond what, frankly, you were seeing in $200 million movies a few years ago. And that's pretty much where we introduced Octane with Jensen last year at the keynote. We feel this is such an important and seismic shift in rendering that there's a lot of possibilities that developers can create with this, and having it on Amazon is absolutely the best way, in our opinion, to really bring this to market. So just to sort of summarize what Octane's benefits are on the cloud, on Amazon, you can scale from 1 to 1,000 GPUs using really the existing Amazon infrastructure, complex scenes that we used to take hours, rendered in seconds. And this is a service that is available worldwide from Tokyo to Europe. And if you use spot instance pricing, which is the cheapest way to get a GPU on Amazon, and that does work with Octane, the cost can be as low as 11 cents per GPU hour. And that is a huge delta from the hundreds of thousands or millions or tens of millions of dollars that have been typically used to build render farms that up until now really were necessary to deliver this kind of fast turnaround for 3D. We, last year, sort of put that, proved that out with 20th Century Fox. We announced that Fantastic Four, which is a movie coming out in 2015, would be leveraging Octane to deliver real-time rendering, and it was using a version of Octane that could leverage these hundreds of GPUs. The interesting thing is that a year later, that very same service is now available on Amazon, and this is the exact demo that we gave at the keynote last year. That was really a hardwired, complex work of engineering, and now we can basically boot up an Amazon instance. in a matter of minutes. You can go on area.autodesk.com and figure out how to do it. And that ILM model that you just saw is now something that can run anywhere in the world, and it doesn't require a custom piece of hardware. Amazon essentially supports this technology out of the box with our software stack. So in short, cost savings are drastically reduced when you're having an M&E workflow in the cloud based on this stack. There's so many layers where we solve these problems of cost and time. Even something as simple as the fact that an artist can interactively iterate on a scene on a GPU, even one, is a huge step function from where things were before. And we don't want to stop at movies and film rendering. We want to really change the way that interactive 3D experiences are done. And for that, we needed to really focus on game rendering and 3D rendering that's focused on essentially replacing Direct3D and OpenGL. These are the typical APIs that you have for games, or even a viewport inside of any 3D app like Maya or Max. So we created a new renderer that leverages some of the Octane lighting and materials, and that allows us to do cloud gaming, 120 frames per second graphics in the cloud that you can use to stream to goggles or next-gen display devices. There's a huge amount of interest for previs and other things that are a little bit different than just final render. And we have not yet necessarily shown all these pieces before, but now that we're essentially at the point where we've matured our offering on Amazon for offline rendering, we're ready to unveil BRIGADE. And BRIGADE essentially allows you to have the same quality as Octane, but for games and films. And you have an enormous delta from anything that you'd see on a PlayStation 4 or an Xbox, or even next-generation PC gaming in DirectX 12. The entire real-time pipeline in BRIGADE is path-traced, and the art pipeline is physically based, and it's something that we will be showing off in our next presentation. So we look forward to getting more into that shortly. Thank you.